Never teach a class hungry with this microphone. All right, it is recording. I used to have a before I started to use microphones. I used a. Remember when MP3 electronic MP3 players first came out? They were kind of like little sticks about yay big, and you can buy the really cheap ones from Fry's that also has a recorder, but the sound quality is really kind of crappy. Yeah. So I used to have one of those things, and when I still wore shirts, so I put it in the pocket, and that would do just the voice recording. That's before I started to do screen recording. And those things, are interesting because even though they're kind of crappy, but I suppose when they're really like inches away from your heart, it will still pick up the heartbeat. So when I don't talk, there's no other noise or no other sound whatsoever, you can faintly, hear the heartbeat, in the recording. Yeah. Back in those days, I only have each lecture is about a 5 megabyte audio file, and now it's about 1.6 gigabyte. All right, so we'll get started today with the practice exam for next Wednesday. So yes, we do have the second exam on next Wednesday. It is basically the same setup as the first one. It's open book, open notes, paper only. Okay, I'll give you the question text on paper, and you can write down the answer on that piece of paper as well. You might want to bring extra paper for scratch purposes, for scratch paper. I will bring my stash of inexpensive calculators, just in case someone wants to use a calculator for arithmetic stuff. And today we'll go through at least some, if not all, of the practice questions. The practice questions are already online on Moodle. If you go to the topic Libraries and Modular Programming, then you will find X2 practice questions. It is located here. It is a single zip file. When you download the zip file, you can go ahead and unzip it. It unzips into a folder by itself. It is called X2 for Exam 2. And in Exam 2, you will find 7 files right now, or 8 files, but there are only 7 questions. Each one is in the form of a CPP file, which means each one is a program with the question at the end of the text file. Is that okay so far? So where to find the practice exam questions? So we'll go ahead and work our way through these questions today. All right, so here's the first question. The first question is asking you to read a particular program. They all start about the same way, to read a program. This one is asking you, if you read on line 20, starting on line 22, it asks, make an input. Okay, so specify what needs to be the input, the standard input file that will make this program exit. And the input should be just enough to make this program exit, which means if it lacks the last character, the program will not exit. So it has to be just the minimum to get this program to get out. So someone cannot just say, oh, ABC 1 2 3 4 5, exclamation point, just randomly type a whole bunch of gibberish and say, at some point of this input it's going to exit. That's not what I'm asking. I'm asking for a very precise answer where it is just enough to get this program to get out. Are there any questions about that particular criterion of the answer?
So you want it to exit as in exit a loop, or
no?
What do you mean exit?
So when I run this program, what type of input will make the program terminate, stop?
Return 0?
How does it get to return 0? What has to be the input in order for me to get to return 0?
5?
Nope.
The counter has to be
Well, counter has to be at least 5, yes.
Okay.
But how do you get counter to at least 5? That is the question. Okay? All right. So let's go ahead and read this program backwards, because that's not what the question is asking, but indirectly that really is what the question is asking, is how do we get this loop to exit? Is that making any sense? Whenever you have a loop, you have to ask the question, how do we get out of this loop? So in order to get to the return 0 line, which is on line 19, we have to get out of the outer while loop, which starts on line 9. So that makes the condition on line 9, which is counter is less than 5, an important condition, because when counter, as long as counter is less than 5, we're not exiting this loop. Okay, so if counter needs to get to 5 to get out of this loop, let's check how counter is used throughout this program. It is first on line 8, it is initialized to 0. Okay, so the only hope of, maybe I don't have to do a single thing. Maybe counter is initialized to 100 already, so I don't have to do a single thing and the program will exit automatically. No, that's not happening. The only other line that deals with counter is on line 16. Line 16 is just adding 1 to the value of counter. So now the next question is, how do we get to line 16 several times in order for the counter to increment several times, at least get it to up to 5, and then maybe we can exit the program. Yep, go ahead.
5 errors.
Huh?
5 errors.
5 errors. Okay, very good. So you're starting to recognize this is the code that we have been dealing with several times, right? The first time we saw this kind of logic was when I disclosed the answer to the sum project. Okay, that was the first time, but it was in the form of scanf and printf. In the second homework assignment, we used cin and cout, which is also kind of in this form. So we have seen this code already. So in order to get to line 16, now line 14 to line 16 is one single block of code. So we have to get into this block of code. That means this condition has to be true, with the exclamation point, and then we have cin right shift into x. That has to be true for me to get into this loop. So now the question is, what does this mean exactly?
As long as you're able to move input from standard command
As long as you
into variable x.
As long as you cannot, right? Because of the
Right.
negation symbol. Okay, very good. But you interpreted the inner expression correctly. Okay, so let me just kind of briefly explain what the inner expression means. This expression, we have seen it many times, so we kind of know what it is. We want to read something from the standard input file into x, but that depends on what is x, right? X is already declared on line 5. It is an integer. So we are trying to read from standard input file into an integer. I did not specify anything else. Okay, so that means I'm dealing with a base 10 number. I'm not dealing with base 16 or any other bases. But as an expression, this expression returns cin itself. So that means I'm basically saying not cin. Now, not cin doesn't seem to make any sense because cin is a standard input file. How can we negate a standard input file? Well, we cannot. But in the attempt to read to see cin as a Boolean value, it is going through a built-in typecast operation. The built-in typecast operation is basically saying if you use cin in a context where a Boolean value, a true-false value, is expected, then returning true cin being interpreted as true means the previous read operation was successful. If it returns false, it means the previous read operation was not successful. Okay. We kind of talked about that in class 2, and we did some experiments to actually verify that one. So combining the negation operator and the expression itself, this entire thing is basically saying, as long as I cannot, okay, remember this is a cannot, read an integer in base 10 into x, do the following. Now, that means in the standard input file, I must have some characters that cannot be interpreted as the beginning of a base 10 number in order for me to get into this loop. What do I do in each loop, in each iteration? The first thing I did is to clear the error status of cin, because if I don't do that, no further additional read operation can occur. Okay, so that has to be done first. The second operation is just to clear that one single character that cannot be the beginning of a base 10 number. I just read it into an integer, read it into a character, a variable, and just toss it away. It's not useful to me. And then the third thing that I do is increment the counter, and then I go back to reevaluate this condition. In other words, as long as I'm reading characters that cannot be the beginning of an integer, I will keep myself in this loop and increment counter accordingly. Is that okay? All right. So given that we know that, do you think entering A, B, C, D, E, and then press the enter key will get me out of this program? Now that is a very tricky question, because if I type A, B, C, D, E, and then press the enter key, it will certainly increment counter to 5. But can it get out of the inner loop? In other words, would that make the condition of line 11 false?
No.
No, because A, B, C, D, E, and the return key cannot be interpreted as a integer. So the attempt to read an integer will still fail, and as long as that fails, I'm not getting out of the inner loop.
So would you enter in characters that aren't integers and then end it with an integer?
Correct. Exactly. So we can enter A, B, C, D, E, then a 0 or 1, and then press the enter key, and this will exit out of the inner loop. And because the inner loop from line 11 to line 17 is the only statement of the outer loop itself, then it will go to it will reevaluate the condition of the outer loop, and at that time counter would be 5 already, and then we can exit the entire program. All right. So the answer to this question is something along the line of A, B, C, D, E, 0, and then, well, you can either specify the enter key or not the enter key, but either way it will exit. Any questions about this particular question? What I'm asking or the answer itself? Yep.
It's not super important that you put 0 as the number, is it?
When you type 0 in standard in, go ahead.
As opposed to 1 or any other base 10 number.
Any other base 10 number would be fine. Yep. But since I'm looking for the shortest one to make it work, so you have to make it a single digit. Yep. All right. Any other questions? No other questions? And, yeah, go ahead.
And the test next week is going to be on paper as well.
It is on paper. Yep. But it's also open book, open notes like the previous one. Right. So if this one is good, well, let's move on to the second question. The second question, I think, is one of the easiest questions, because you just have to track, what is the current I and what is the current J when you read this program. All right, so let's start from the beginning of this program here. On line 2, we have is that a local variable or a global variable? It's a global variable because it is not inside the block, right? Okay, so inside main, which is the entry point of the entire program, I have a integer j. So is that a local or global? That's a local variable because it is inside a block of open and closed curly brace. So when I say I equals 2, which I am I referring to?
Global.
The global one. Okay, so the global I gets a value of 2, and then the local j gets the global I, which has a value of 2 plus 1. So this j now has a value of 3. Any questions? Nope. Okay. So moving on to line 9 doesn't do anything. Line 10. So when I'm on line 10, which I am I referring to?
The local I.
The local variable I. Okay, the local variable I is declared on line 9. Okay, so when there's a local variable I, it quote unquote hides the global variable I. So I no longer have visibility of the global variable I. So that means when I say I gets j plus 2, I am only storing the value of 5 into this local variable I. It does not change the global variable at all. Is that okay? So at this point, we have one local variable I and one global variable I. The local one is now updated to a value of 5. Now when we enter this inner scope here on line 12, then we have another local variable j. In other words, at this point, we have 2 variables named j inside main. But it is okay because this j, which is declared on line 12, is now hiding the other j, which was declared on line 5. So that means at this point on line 13, I have no visibility whatsoever of the j that is declared on line 5 anymore. Is that okay? So the j that had a value of 3 is no longer accessible to me. This is a new variable j. This new variable j gets the value of I. Which I am I talking about? It is this one here, which has a value of 5. So this j has a value of 6. So by the time I do the C out, it will first print 5, comma, 6, and then the end of line. That would be the output of this program. Are there any questions about this particular question? So this one basically tests to see if you understand the scope of global variable as well as local variables. Okay, but in the case of a local variable, it depends on which scope we are talking about, because we have several inner scopes here. We have one scope here, and then we have one scope here, and then we have another bigger scope here. But all of these scopes are local. Are there any questions about this particular one, about question 2?
How do the block statements get nested within the other block statements?
Sorry?
How do those block statements get nested within the other block statements?
Just like that.
Okay. Well, I was just curious, like, how does that?
Why?
Yeah.
I do it all the time because sometimes I have uses of one particular variable, but it has no other use outside of the context of, like, let's say 3 or 4 lines. I don't want that variable to be visible outside of those 3 or 4 lines. So I would typically open a new scope, make a new variable, only use it within those 3 or 4 lines, and then close the scope. So this way I cannot accidentally use somebody else's variable and clobber the value. Typically is a technique that you use for longer subroutines where it is kind of hard to keep track of which variable is currently in use. You just say, okay, here's a new one, and I only need to use it like within these 3 or 4 lines, and after that I have no use of that anymore. You close the scope. You can also use it for clarity purposes. For instance, if there are several lines, they collectively do one particular thing, you can use the open curly brace and the closed curly brace to emphasize that these few lines belong together. And then at the beginning, use the / to kind of comment and say that this block of code serves this one particular function. So it's easier to read your code instead of reading like 20 or 30 lines that are completely flat. Now you can group them into like chunks, and chunks, and each chunk has its own comment.
And it knows to get nested because we have after initializing main, we have the open curly brace and then the block, and then another open curly brace indicates that to the compiler that it's not going to.
Yeah, the compiler has no problem with parsing this code. This is actually all of these programs compile. Yep. All right, Q3, question number 3. Now, question number 3 is one of the kind of more difficult ones. It's not the most difficult. This is the one that is kind of similar to the one that we talked about in class the other day, the factorial program. This one does not do factorial, but we want to know how to keep track of these recursive subroutines. So let's take a quick look first. The question is simply asking what is the output of this program. Okay, so all you have to do is to figure out what it is going to output to standard output file, and that is your answer. That's not the hard part, because that part just requires you to track down where the C outs are. The difficult part is to figure out when do we execute line 7 and when do we execute line 9, and keep track of the value of R as well as N all the time, so that you know which value we are printing when we get to line 7, line 9, or line 14. Okay. So now is a good time to kind of talk about how do we run a program like this, but on a piece of paper. Now, if this is a test where you are allowed to use G++ on the computer, the answer is trivial, right? You just copy, paste, compile, copy the answer back, and you're all done. But that kind of defeats the whole purpose. So this is a paper test. So how do you do something like this on a piece of paper? Well, for those of you who took my cisp360 class, you kind of have the basics already of how to do this. Okay, we use all the columns and whatnot. If you have not taken my cisp360 class, as I said in the previous one, you should take that again. You should take my cisp360 class and then take this class again. I'm just kidding. No.
So you
No.
semesters.
Wasted 2 years.
Or you can use the next week to watch all the videos that I have captured for my own cisp360 class, so you'll be ready again. No, you don't need to do all that, okay? But what you do need to do is to figure out a way to keep track of things and also make sure that you remember one thing. Local variables and parameters are not on a per function basis. They are on a per invocation basis. So each invocation gets its own parameters and local variables that are independent from the parameters and local variables of another invocation. Are there any questions about that statement?
You said invocations. Could you explain that a little bit more?
An invocation is a call. An invocation means two things. Okay, in terms of execution duration, it is going from the time when the subroutine is called to the time that the subroutine returns. That duration of time is one invocation of a subroutine. But in terms of storage, each invocation also has its own version or its own copy of the local variables and parameters. I'll give you one analogy. Okay, a function. Okay, this is a good one. A function is like a U-Haul truck. Okay. All right. So a U-Haul truck can be sitting in a U-Haul U-Haul place doing absolutely nothing, right? So that's a U-Haul truck. It's just a truck. Okay. An invocation is someone renting it. It's one particular quote-unquote rental arrangement. We can see it that way. A contract. Okay, that's a better term. So a rental contract is a invocation. So that means, for a U-Haul business that is in the wrong neighborhood, when nobody's moving, no one needs to rent a truck, that truck is just sitting there doing nothing. It's not getting invoked. There are no invocations. It's the same thing as writing a subroutine in a program like this, but it's not being called at all. Okay, that's just a subroutine with no invocations. Is that okay?
Yeah, so pretty much like in X, but not using X. Is that what you're trying to say?
It's actually a little bit worse than that because, okay, if I write a subroutine here, and I say void g void, okay, so here's a subroutine, simple subroutine that doesn't do anything, does not return anything, does not need any parameters. It's just a subroutine. It's just a truck sitting there doing nothing. Okay. Now I can be even more elaborate about this and say, oh, you know what? G is going to return an integer, and it's got x1, x2, and x3 as parameters, and it's got local variables too. Let's say we have t as my local variable, and specify a whole bunch of code here. It is still a truck. It's just a bigger truck sitting in the lot. Nobody's renting it. Okay, so you're still having no contracts whatsoever. Now, what is the difference between a truck and a rental contract in terms of duration, like how long it will last? The truck is there forever.
Yeah, this will last long.
A function is here forever. It's sitting there. It's just sitting here doing nothing. What about the invocation of a subroutine? It definitely has a start time and an end time. Even main has a start time and an end time. Is that right? So it's the same thing with a rental contract, unless somebody run the truck into the ocean or something. Okay, so the rental always has a beginning when someone is signed off the contract and drove the truck off the lot and come back with a full tank of gas, right? Same thing here. So are we doing okay so far with this analogy? One is kind of more of a runtime thing, and invocation is a runtime thing. And then the subroutine itself, the function itself, is more of a compile time, kind of more static kind of thing. Is that okay so far? All right. So what about recursion then? Recursion is difficult to understand when we're using this truck analogy. It's not. We only have one truck. Even with recursion, it is still one single truck. So what are we doing with this analogy? It doesn't seem like the analogy is helping us at all. It's called the subletting of a U-Haul truck. Okay, so let me go ahead and explain the subletting of a U-Haul truck. So let's just say that I'm the first renter of a truck. Okay, I go to U-Haul, I checked out the truck, a 14-footer, because I have to move something. And along the way, I came across with George here, and George said, hey, Tack, I can see that you're driving a U-Haul truck. You know what? I got something to pick up too. I have to go to Home Depot and pick up something. And I'm gonna say, well, that's okay. I can sublet the truck to you. All right? So now there are two contracts related to the same truck. There's only one truck, but now we have two contracts, right? So when I rent the truck or sublet the truck to George, George decides to drive it around, and then he comes across John.
Yes.
Yep. So he comes across John, and John says, I need to go to Green Acres and pick up some manure, and I don't want to use my own car for that. So George said, sure, hop on, and I'll sublet my truck to you to go to Green Acres, right? So now we have three contracts, three rental contracts on the same truck. All right? So when John is done with transporting the manure and clean up the truck after that, who is John going to return the truck to? The U-Haul place, me, or George? George, that's right. Okay? And George will continue with his trip to Home Depot, okay? Pick up, concrete blocks or whatnot. Okay, I don't know why you want to get some concrete blocks for a programming class. Maybe you're building a stand for your computer, right? So when he's all done, what does he do? Does he return the truck to the U-Haul place? The U-Haul place goes like, who are you? Right? Why are you returning the truck to me? So he has to return the truck to me. I have to finish what I'm supposed to do, and then I'm the one who returns the truck to the U-Haul place. Is that okay? So this is kind of why we can have one single subroutine and have many different invocations of the same subroutine. Is that okay? Okay, so I'm kind of getting the invoking or the calling and the returning part of a subroutine. What about the local variable and the parameter stuff? I mean, that is not going to work well with a U-Haul truck. Well, I can use like maybe two things on a U-Haul truck that can illustrate that concept. When I first rent the U-Haul truck, the U-Haul truck place says, okay, so here's the truck, but I want everything to return to its original state as it is now, including all of the radio stations. Because they have everything tuned to like an emergency channel and stuff like that, right? So I got the truck and I go like, okay, I'll write down all of the channels, but now I get to, I can actually change all the settings, right? The first thing is I will pull the seat all the way to the front because I'm short. Now, most of you are much taller than I am, but if you're as short as I am and you're in a U-Haul truck, it's pretty difficult to drive one when the seat is all the way back. I can hardly see over the dashboard.
No, 'cause I'm short. I know your pain.
Yep. So I changed all the radio stations, I changed the seat settings and whatnot. And George is a little bit taller than I am, right? So when I sublet the truck to George, you know what I say? I tell George, well, you can do whatever you want, but before you return the truck back to me, you have to record all the settings, right? And John is even taller, so when John gets the truck, he's going to push the seat all the way back again. So now we have settings related to the radio stations and also the seat arrangement. And there are 3 copies. Why are there 3 copies? Because there are 3 renters, 3 contracts kind of stacked up. Is that okay so far? Those are my local variables and my parameters. So every time I sublet the truck one more time, there's a new copy of local variables and parameters. Are we doing okay so far with that analogy? Now with that analogy, now let's go ahead and see how we can trace this particular program to find out what it does, but without actually compiling and running it. It actually compiles and runs too, but that's not going to help you understand how or why it works. Okay, So the way we do it is I'm going to use a more or less simplified way to represent all of this stuff here. In my own previous cisp360 class, I use a kind of long and lengthy way to do it. You don't have to turn this in the test, okay? But the danger of not turning this in is some people will just say, oh, I can track everything in my mind, I don't have to write it down. And trust me, it's not that easy to track everything down, so I would certainly write it down on a piece of paper. So I would track the execution of this program, which starts on line 21. Line 21 seems to be a pretty easy line to track. I mean, it's outputting the result of f of 2 and the end of line. Okay, what is the big deal? Well, the big deal is I cannot print anything yet, because I cannot finish the printing until I know what f of 2 really is. Okay, so the way I track this is to say on line 21, we have C out, blah, 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 and it calls f of 2 and end of line here. This is only for tracking purposes, so it doesn't even have to be like completely aligned here. Just enough to so that you can remember what else you have to do here. Okay, so as a result of this, it's calling f, right? Because we can clearly see there's an invocation of function f. So it calls f, but when it calls f with a parameter of 2 to parameter n, an argument of 2 to parameter n. So when I use something on a different quote-unquote column, like in this case, it's kind of like on a column onto the right-hand side of the original one, it's representing a new contract. Okay, this is the first contract, the first rental contract of this particular subroutine. It's the first time we invoke the subroutine. Okay, all right. So I'm calling f of 2. So in terms of execution, where do we go? We start on line 5 because that's the first line of the subroutine that actually does something. And it's comparing n to 0. Which n are we talking about? That's easy. We only got one n. Okay, the only one n is 2. 2 is greater than 0 is true. So in this class, I don't need to write anything here. I just need to say, oh, where do we go next? The condition of line 5 is true. Where do we go next? Line 7, that line 7 is correct. So line 7 is an output line. It says, output the value of n to standard out. Okay, that's fine. I'm just going to use all the way over here and say, C out with a value of 2. All right, that's what line 7 is going to do. And now I'm continuing with line 8. Line 8 is a little bit kind of tricky because line 8 says I want to store the value of f of n minus 1 into R. That means I have to call f again. So I'm going to say, oh, okay, this has to call f again. So this time when it calls f, what is the value of parameter n? Okay, this n refers to this n here. N minus 1 is 2 minus 1, which is 1. So this time when we call f, it has a parameter of 1 to n. Are we doing okay so far? So this is my third column. This is my first column representing main. This is my second column representing the first invocation of f. This is my third column representing the second invocation of f. All right, we have seen this already. When we call f, we start execution on line 5. On line 5, we evaluate whether n is greater than 0. Which n am I talking about? Am I talking about the 2 or the 1? The 1, that's right. Even though both are greater than 0, knowing which one we are referring to is important. So 1 is greater than 0 is true, so we end up on line 7 again. Okay. So line 7 says we have to output the value of n, which we already know is the n that has a value of 1. So now we have an output of 1. Then we move on to line 8 again. Line 8 is the recursive call, which means on line 8, we are saying, okay, we want to store the value of f of n minus 1 into R, but I can't do the assignment operation until I know the value of f of n minus 1, which also means at this point, I'm going to call f again. But when I call f again, it is a new invocation. As a new invocation, it has its own parameter n, which has a value of what? 0 this time because n minus 1 refers to the n that has a value of 1. 1 minus 1 is 0. So this last invocation of f, which is the third invocation of f, starts with a value of 0 in parameter n. And once again, I start with line 5, but this time when I get to line 5, it is comparing n to 0. N is already 0. 0 is greater than 0 is false. What happens when the condition is false with a conditional statement?
Yeah.
Go to the else case. False.
So 13.
Yep, we go to line 13. So line 13 is here. And line 13 says R gets 1. Okay, fine. But the R is now on this column here because we are on the third invocation of f, or the rightmost column at this point. Are we still doing okay so far? Why I write R equals to 1 all the way out there on the right-hand side?
No, I mean, I'm following how the program is working. I'm really confused as where you're putting everything.
Because each column is basically is representing one invocation.
Oh, so it probably would make more sense if you were like on a spreadsheet or something, I guess.
Right. It is kind of parallel to a spreadsheet. If you guys want to, you can kind of imagine that whenever you call a subroutine, the local variable also starts to exist, except it has an unknown value. Is that okay? Is that better?
Yeah, it's weird with no lines, that's all. It just looks like, that's all.
Yeah, you
fine.
have to find a way to, it's up to you to decide how you want to represent it. This is the best way I can do it in a text editor without going full-blown like a cisp360. Okay, so on line 13, we give R a value of 1, and then where do we go after line 13? That's an easy one. Line 14, right? Line 14 is not printing the value of R. It's printing the value of n. And what is the value of n at this point?
0.
0 is correct. And after line 14, where do we go? We go to line 16. Okay, go to line 16. And line 16 says return 2 times R. And by the way, what is the value of R at this point?
1.
So we are returning a value of 2. Okay, so I'll just write down return 2 here. Now, this is a very important pivotal point, because right now I'm at the end of one invocation of a subroutine. Okay, John is done transporting his manure. Okay, now it's a very important point because now he has to decide. He has to return a value to George. So let me see what would be a good value to return when you're dealing with truck rental.
Maybe because if we're going to go through
Miles, number of miles. Okay, so now so John is basically saying, okay, according to the odometer, I just drove 26 miles. That's a lot of miles to get manure.
Yeah.
So I just drove 26 miles. Who wants to know? You do. Okay, and you were just about to do something that requires the number of miles, because you have to figure out how much money.
Because you have,
Yeah.
you have stipulations.
Because you're doing some calculations based on the number of miles that John is driving. So now you can resume what you were doing before that needed to know how many miles John drove on the truck. Okay, so that's the same thing here. So at this point on line 16 of the third invocation of f, it is basically saying, okay, I got an answer here. Who wants to know it? Who needs to know it? Guess what? Why did I get called in the first place? It's right here, right? So I got called from the second invocation of f on line 8. So where should I go back to? Line 8. Yep. So I should go back to line 8 of the second invocation of f, which was trying to figure out f of n minus 1. But now we know f of n minus 1 is 2. So R gets 2. Are we doing okay so far with this transition? This is really the most important part of this trace. Going forward is actually usually pretty easy. Okay, it's when we are going back, then we have to figure out how do we get here in the first place. Oh, I remember now. That call is why I have this invocation So the result of this invocation needs to go back to whoever asked the question to begin with. Are we doing okay so far? Associating the result of returning to the continuation of something that relied on the value of f of n minus 1. Yep.
So why wouldn't we be returning r equals 1?
Because it is returning 2 times r. The value it's returning cannot be in the form of r, has to be an actual value. So since r has a value of 1, 2 times r is 2 times 1, which is 2. So we are returning just a value of 2, not anything that involves r. Okay. All right, so we are now back to line 8, and line 8 says, cool, I can now finish my operation, which is to change the value of r to a value of 2 in this case. After line 8, where do we go?
9.
Yep, line 9 is sequential to line 8. And line 9 wants to print the value of r not n, so it's going to print what? 2. And then we go where? Line 16, very good. So on line 16, we are once again returning 2 times r. So what is the value that we are returning? 4. Yep. So once again, I'm holding a value and saying, okay, I have the result of this calculation. Who wants it? Whoever called me in to begin with, right? So why was it called to begin with? We track it down here. Okay, this instance or this entire invocation existed only because I was called from line 8 of the first invocation of f. Okay, so that means now we have to go back to line 8 and say, oh, you know what? Somebody asked me earlier what is f of n minus 1. The answer is 4. Is that okay? All right. So now that we know that r has a value of 4, we move on to line 9, which prints the value of r. So now it's going to print 4. And after line 9, we get to line 16. Line 16 is returning twice the value of r. So now we're returning 4 times 2, which is 8. And who wants to know? Who's asking?
Me. Well,
It'll be the main program.
yeah, me.
Yeah, line 21 is in the main program, and the main program only has one invocation. I'm not doing main recursively, which you kind of can, but it can be also more confusing that way too. So we're now going back to line 21, because line 21 is the one that call the first invocation of f. Yep.
The way I was doing here was that actually the first time when main called f of 1, we left for line 8. So when we return 8, we should be returning it to main's invocation of f. So therefore we should go back down to line 9. So the way I have it is you end up printing out 8 twice because
No, we only print 8 once.
It prints once.
Yep, it will only be printed once.
The
And line 8
returns-
is, and the value of 8 is only printed because of line 21.
yeah, but so when f calls it prints it out before it returns.
But it prints out r, not twice of r. On line 9, which is here, it only prints out r, and r at that time has a value of 4.
So the second invocation is returning 8.
Well,
The second invocation returns a value of 4.
the
the
return
fir-
doesn't print anything.
Yeah, no, I got that part. It's just what I'm saying is, I guess I tracked it wrong. Then I'm pretty sure that the second invocation is but I guess. So either way, I got one.
Well, it is important to clear up, why it is returning 8 but not printing 8.
Well, yeah. So what I'm saying is, I still think I'm correct because the way
Let me turn on the row number so you can refer to it. Now we have 2 sets of numbers, making it even more confusing,
Yeah, I'm
right?
saying that didn't really help out. I was cool with the one set, but so yeah, I'm not gonna look at that. But so what I'm saying is main's gonna have its own printout because that's the way we call it. When we call f, it's in the printout statement, right? Well, f has its own printout. So once
Yes.
it gets R, it's going to make a printout. So what I'm saying is,
Wait, hold, say that again.
So, but F has a printout, has a standard.
F has a print. F has 3 prints. One is on line 7, one is on line 9, one is on line 14.
So let's say like the very first time, like this wasn't recursive, if we just returned 2, if like we called F of 2, the way I see it is that we would print N, which is 2, we would give R, let's just say that wasn't recursive, we just gave it 2.
Okay, we
Then
change this to 2.
Yeah, it would print, R would be 2, it would print R, which is 2,
Mhm.
and then we'd be returning, because we'd be down at line 16.
Correct.
And standard out would print that value. So we'd end up, there'd be 2 prints because F would print its own, and then standard out is going to print the value of.
Okay, but return does not print automatically.
Yeah, but line 9 does inside of that.
Line 9 does, right? So if this is just 2, if this is not recursive and it's just a constant of 2, then it would have printed 2 the first time because of this, printed 2 because of this, and then printed 2 again because of this.
That's what I'm saying. So we'd have 2, it would be 2, 2, 2.
Correct.
So as we come back, when we return 8 to
Oh wait, hold on a second. That is not true because before we return, we double the value. So it would have printed 2, 2, and 4 over here. Because we are returning a value that is not R, we are returning twice the value of R.
All right, I'll let you finish.
And that's why, when it has a value of 4, when R has a value of 4, we are actually returning 8.
Yeah.
But it's only printing the value of R, so it's only printing 4. Now, when we return 8 this time, we have to return to the place that called me to begin with, which is on line 21, this part of line 21. So now we return execution, continue execution on line 21. Line 21 finally can do whatever it is supposed to do, but it's now printing the value of what? What is it printing?
16.
Nope.
8. Yeah.
Just 8. It's printing whatever f of 2 is, and the invocation, the first invocation of f is returning a value of 8, and that is what I'm printing on line 21.
Not saying that I don't believe you, but just from my
No,
side.
just run the program.
Can we run this?
Yeah, run it. That's the answer.
Okay, so this is the trace of the program, and doing it this way can be confusing. Okay, you kind of have to imagine that you draw a line here, draw a line here, draw a line here, and draw another line here. So you separate the whole thing into columns, and then each column is representing one invocation. That will help you make it easier to understand. Is that okay?
Yeah, I think it was the whole like I might have had like an extra invocation because I got all the way up to there and I basically ended up having 2 print 8s.
No, you would not have 2 print 8s because the only reason why it's printing a value, but it's not return the same value that it prints. This is R here, but this is twice of R here.
Yeah.
That's why. Okay.
Yeah. Thank you.
All right. Now, having said all of that stuff, let's go ahead and compile this program. See whether it works or not. So we compile with -G so that we can use GDB. -O, this is q3.cpp. This is the program, put a breakpoint on line 21, run the program. We are now on line 21, and I want to kind of do it side by side. And there's one way to do it. I have to change one setting to make this really easier. And focus control, we want to say focus follows mouse. Okay, that should do it. All right. Yep, there we go. Okay, so now we can single step on line 21, and it goes to line 5, which is this line 5 here. We single step again, it goes to line 7, which is this line 7 here. It should be printing a value of 2. It doesn't actually do anything. It appears that it didn't print anything. It's because cout, when you're printing something, is buffered. In other words, it doesn't print it out directly to the screen all the time. In this case, it's saving up all the stuff that it's supposed to print until it encounters end of line. Then it will flush the buffer and actually get everything out to the screen. Because otherwise it would be printing kind of piecemeal, and it's very inefficient. So this way, it's kind of like saving up a lot of stuff to print, and then it would just kind of dump off all of that stuff to the screen all at the same time.
Printf doesn't work like that, right? Printf.
It works the same way. Printf would do the same thing. If you don't specify an end of line, it doesn't do any printing, or it can be. It is still buffered. Okay, so now we're on line 8, which is this line 8 here. So when I single step this line 8, this is the pivotal. This is one of the pivotal points because it continues execution on line 5 because we are now calling f again. Okay, but this is also a point where you want to do a BT or backtrace, which shows you that we are currently in function f on line 5. But the reason why we are here is because there's a call to f on line 8 in function f. This is the recursion. Okay, we were getting called from another invocation of f, and f eventually, is called from main on line 21. So backtrace is really helpful because it really shows you how you got here in the first place. So getting back to the trace here, we are now on line 5. So the next line is going to be line 7, and the next line is going to be line 8, and then back to line 5, and then we go to line 13. And then from line 13, we go to line 14, which is the output. And then from line 14, we go to line 16, which is the return. Now this is the other pivotal point because we are now at the end of the last invocation of f, and we are starting to unwind stuff. Okay, so here's the question. We are now on line 16, the end of the subroutine. Where am I supposed to go back to? Who called me to begin with? Line 8. Okay, so when we single step, it goes back to line 8. Okay, tracks line 17 too. But we basically go back to line 8, but at this point r should have a value of 2 because that's what it's supposed to be. So we say print r, and it does have a value of 2. Okay, so are there any questions about keeping track of the invocations? Is that okay with you guys?
Can you run it at full speed so that we can see the rest of it? Are you done here?
Just continue. And it prints 210248, 210248.
Standard deal, okay?
Sorry? But this is a very important program to understand because if you understand subroutines in general, and this one is puzzling you, that means one thing. Okay, it means you're associating local variables and parameters on a per function basis. So that's why having one invocation per function is a-okay, but having a function calling itself is not. So that means you have to shift your understanding and say, okay, local variables and parameters are not on a per function basis, it is on a per invocation basis. Local variables and parameters are rental contracts, and then the function itself is a rental truck. You can sublet as many times as you want. Is that okay? I mean, that really is a very important part of subroutines, because I don't want you to move on to the next few classes without really understanding that local variables and parameters are on a per invocation basis. Is that okay? All right. It might take some time to sink in, so you might need to revisit this code and just kind of try to trace it again by hand and see if you can get a better understanding. All right, so that is question number, which one was that? 3. Okay, so let's go to question number 4. Question number 4 is I would say, easy one. The question is first asking, does this program contain an error at compile time? So when you compile the program, does it complain about anything? If so, what is it complaining about? On which line? What do you think?
Yes.
Why would it? Okay, what is it complaining about?
Well, I don't know the exact error, but I think it has something to do with line 2, so I'm not really
line
sure
2.
Exactly what the extern, when it's initializing x is.
Okay. All right, so let's go back and try to remember what extern means on line 2. Okay, line 2 is the declaration of integer x. But integer x is not being defined here. I'm not creating integer 2. I'm simply saying somebody else has an integer, global variable integer x, and I'm using it. I might be using it. Okay, this is simply saying I am assuming. Okay, this is an assumption. Okay, from here on, this is something that I should take a note of. The word extern means assume. Okay, without the assume, it is create. So the lack of assumption is basically I am making it here. Okay, this is variable x and I own it. This is saying assume x is an integer and somebody has it.
Okay.
That's what it's saying.
So, but there's no link to
That
what
is
that
correct.
variable is.
That's right. So as far as the compiler is concerned, the compiler is 100% A-OK with this. Because the compiler says, okay, somebody, meaning the programmer, you, told the compiler and say, assume there's a variable x that's a global variable. Somebody's going to define it, okay? May or may not be here, but it is an integer, and the name is x. It's a global variable. Now, as a global variable, does the scope of a global variable include line 5 and line 6 of this program? As a global variable.
Yeah, so is that changing?
Yeah, sure, right? I mean, that's the whole reason why a global variable is called global. Everybody can see it. So that's why, as far as the compiler is concerned, this is perfectly okay. There's no problem whatsoever. Is that okay? All right. All right. So the answer to the first question is no. There's no compile time error whatsoever. The second question is if this program does not contain a compile time error, does it contain a potential link time error? And if so, what is it? Now this is actually a poorly phrased question because you guys can say that yes, there are potential link time errors, but not point to the right one, the one that I want you to point to. Okay? Okay, so let's think about why the compiler or why the linker may complain when you link the object code of this particular file to the rest of the program. What can potentially be a problem? Now, I will first explain the one that I intend first, then I will explain the ones that I did not originally intend.
Is the extern going to be a potential linking problem because we don't know if it's in our library?
Right, so the extern is a problem because extern means assume, right? Assume there is a global variable x of the type integer. Well, that's an assumption. What if all of the other object files, none of them, all of them make assumptions, but nobody actually makes it? Then we have a problem because the linker says, yeah, I'm okay with you using x as an integer, but where is it?
I thought maybe I heard you say it also doubles as a creation, but not a full creation as far as like a declaration. It just means
It's an assumption.
it means like you're allowed to use it.
Right.
It actually doesn't exist yet.
Okay, remember how I talked about the compiler is a translator,
Yeah.
and the linker is more like a person who's putting everything together and resolving all the references. So this is more or less extern int x. It's basically saying assume this character exists.
Yeah.
Okay, so throughout this manga, this particular volume of the manga, I assume that character does exist, right? And for people who don't want to have to read again, all of the other volumes, I include a little footnote and say, turn to page, and then I leave a blank here for more information about this character. That's what I'm doing. That's what I'm doing here.
And the link is
Okay,
supposed to put the page
so the
number.
character was not created or explained, or it's not explained in this particular volume. I'm saying some other volume has an explanation of this particular character. Turn to page blah 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 for references. That's what I'm saying here. So this is only one volume. Okay, so I have a little, let's say, post-it on the side after I translate the manga from Japanese to English. There's a little post-it on the side of this page to say, okay, I'm referring to something that is based on an assumption, so whoever is linking needs to resolve this. Okay, there's a blank page number that needs to be filled in. Is that okay? So in another volume of the same manga, okay, maybe I have the actual definition of this character. Okay, so this is Naruto, and this is the the story about Naruto. All right. But what if that volume is missing entirely? So now I have a reference to Naruto, but none of the volume is explaining who this character is. So whoever is putting all the volumes together into a bind book, manga, is going to have a problem, because this little post-it here where I'm supposed to insert a page number, I cannot find a page number for that because it does not exist. So the linker can have a problem when X is not defined anywhere within all the files. That is the intended answer. The unintended answer is, what if another file also defines a subroutine main? Yep. Now you have you also have a link time error, because now the linker says, okay, main is the entry point of the entire program, but you can only have one single entry point. It's not a quantum computer. You cannot have two simultaneous entry points. But that was the unintended. I just thought about the question and go like, oh man, that's a bad way to ask the question, because somebody can say, what if the other file has also main? Then the linker has a problem with that too.
But why would we assume that another file would have main? That seems counterintuitive to me for some reason.
Well, you can accidentally do that. I do it all the time. The reason why I have this kind of problem all the time is I write test subroutines within the same object file. But in order to have an entry point to test the functions in a file, you need an entry point, you need a main. So I would put a main in an object file that is not intended as the main entry point of the entire program, just to test that particular module. And if I forget to take out that main, the linker is going to say, hey, I got several mains here, which one do you really want to use? Pick one. Choose one wisely, right?
So what are you looking for here as an answer then? When I read it initially, it looked like a specific error you were looking for. That's
The expected answer to this one is the linker complains if no object files include the definition of X. Because this really is not a definition, this is a declaration of X. It does not actually allocate the storage for global variable X. It simply says, assume X is a global variable of type integer and use it as such. That's all it's saying. For those of you who know C and C++, C the preprocessor, I should probably do something like this. Define assume as extern. So from here on, I can say assume. Now take it back. Undo. Because it really has that meaning, has the meaning of an assumption. All right, is that okay? Are you good with this?
yeah, it's like I knew that there was a problem with it, and that it had to do with line 2. It was just
Okay.
the fact that you broke it down and said, asked if it was a compile, like if a compile time error or linker error, and I to me an error is an error, I guess. It's just, you know what I mean? It's wrong.
Yep.
Can you go over the difference between object file and header file?
A header file is different from an object file. An object file is the product of compiling a program.
The ones and zeros, right?
The ones and zeros, they're basically instructions that the processor understands already. Okay, compiling is, remember, convert is translation. English to Japanese or Japanese to English. That's translating or compiling. But after you compile or translate one volume of a book, you're not ready to publish the book, because it might have references to other volumes, other chapters, and whatnot. So you need someone to put all the chapters together and make sure the cross-referencing of the chapters work out just okay. That's the linking part. So each individual translated chapter is an object file. The original version is a source file. The quote-unquote header file is something that you can just use #include to include into the source file. It's basically as if the content of the header file is a part of the source file that you're dealing with. Is that okay? Okay. All right, so this is Q5, which is another recursive subroutine. And this one, I'm lacking the question down here, so I'm going to give you the question. What is the output of this program if the input in our standard input file is 1, 2, 3, and then followed by carries return? In other words, when you run this program, you just type 1, 2, 3 on the keyboard, press the enter key. Then what is the output of this program? That's what it's asking. Okay. Does everybody kind of understand what I'm asking, what the question is asking? Okay. All right. So this is another recursive subroutine here. It is recursive because f contains a call to f itself. Okay. We got about 10 minutes. We should be enough. That should be enough to clear this particular question. So we're going to do something like what we did before, kind of a trace like this. So we'll go ahead and start with from. I can see how much you guys like this. I'll have more of these later.
Okay. We're doing a review again on Monday as well.
We'll do another review, a continuation. So what I said in the earlier class is I'm going to produce the YouTube version of Q5 and Q6. No, this is Q5. So Q6, Q7, and I'm not even a fan of all these. So Q6, Q7 will be in the video. I'll publish it on YouTube. And on Monday, we can go back and review any topic you guys want to related to the practice questions. Okay. All right. You caught what I said earlier, right? But my neighbor has a Q7. I don't have one. I might own one after 10 years. Get a 10-year-old Audi. Then I cannot afford to fix it. Okay, so we start execution on line 19, right? Because that's the first line in main. So on line 19, I want to print something, but I can't do it because whatever I'm trying to print involves the f of 0. Okay, I need to figure out what is the value of f of 0 first, right? So this is the context that calls f, the first invocation of f. And the first invocation of f has a parameter n starting with a value of 0. Is that okay? Because at this point it is quite clear that I'm calling f with a value of 0. So in the first invocation, n starts with a value of 0. And at this point, I'm going to shift my representation and just spell out what is r at this point. R is unknown and so is ch, because they are local variables, and all local variables start with some unknown gibberish value. So we have to make sure that we initialize before we use those. And then where do we go? After line 19, what is the next line that I'm going to execute? The first line in the subroutine that we are calling, which is line 6 would be a good place to start. Now, line 6 is kind of a funky little line because it is a conjunction. Okay, it's a big conjunction with 3 components. So I'm going to point out each one, and I will have you guys tell me what it does. Okay, this thing does 2 things. So I would ask you, what is it doing to ch, and what value does it return when the input in standard input file is 1, 2, 3. The first character is the digit 1. Okay, so to answer the first question 1, what is ch? What does this call to scanf? What does it do to ch? Ch stores the character of 1, so it has the ASCII code of 1. Is that okay? Yeah. Okay, now to answer the second question. I'm using it as if it is returning a value. Scanf does return a value. What does it return? It returns a non-zero. It returns exactly 1 in this case because I successfully read 1 character. I was asked to read a character. I read 1, so I returned 1 because I read 1 thing correctly. Okay. What is the meaning of 1 in the context of a conjunction? It means true. So now we have true and something. Oh, I remember something about lazy evaluation. Can I stop here? Can I be lazy?
No.
Why not?
Because it's an and, it's not an or.
Exactly, because with a conjunction,
Not a disjunction.
you cannot just say it is going to be true just because one component is true. false is the value that you can shortcut and say, I'm done here with a conjunction. Okay, so now we have to evaluate the second condition here. Now the nice thing about a conjunction is it is always evaluated from left to right. So by the time we get to this particular comparison, the scanf must have succeeded already. In other words, CH is no longer a gibberish, or uninitialized variable. It has to be initialized. In this case, with the ASCII code of 1. Okay. Now, without even giving you the entire ASCII table, do you think the ASCII code of 1 is less than or equal to the ASCII code of 3?
Yes.
What is your answer?
Yes.
Yes.
Yep. Okay. So the answer is yes. The ASCII code of 1 is less than or equal to the ASCII code of 3. So that means this condition is
True.
true. Okay, so we got true, and I know we cannot quit just yet. So we have to evaluate the third condition now. Do you think the ASCII code of 1 is greater than or equal to the ASCII code of 0?
Yes.
Yes. So the answer is true, true, and true. Okay, that means the entire conjunction is true. So we have to get to line 8. You guys were wishing it was false, right? I mean, so we don't have to do the recursion. Okay, so line 6 is true, so we have to move on to line 8. So line 8 is R gets F times F of n times 4 plus CH minus the ASCII code of 0, which is quite a mouthful, right? All right, so let's figure out what this is. Which n are we talking about? What is the value of n?
And that we got, which was 0.
N has a value of 0 from here, okay? And also by the time we get to line 6, CH also has the ASCII code of 1, just to be complete here. Okay, so n has a value of 0, 0 times 4, plus CH minus 0. CH is quote 1 quote, which is the ASCII code of 1, minus the ASCII code of 0. And what do you think that would be?
So wait, when you're doing the ASCII code, we're not talking about, like, say 31, or we're going to use the integer value?
Well, I am talking about the ASCII code of 1 is actually 49. The ASCII code of 0 is 40.
Okay,
48.
Indexable, yeah. Okay.
Yeah, but since they're consecutive, they're right next to each other. I don't really need to know the exact value. I just need to know the difference.
Oh yeah, because the math will still work out the same.
But the math will work out. 0 times 4 is 0, and the ASCII code of 1 minus the ASCII code of 0 is just 1. I don't even need to know exactly what they are. I just need to know relatively, are they right next to each other? And the answer is yes, they're right next to each other. So now we are actually effectively trying to find out what is f of 1. Okay, what is f of 1? I don't know. We have to call, right? So this calls f, and this time n is 1 to begin with. And since we're doing this, we might as well say, yeah, we have a local variable r that is unknown. We have a local variable ch that is unknown. And we start on line what? Line 6, okay? Now, I don't have to spend nearly as much time to explain line 6 this time because we have 1, 2, 3, and the carriage returned as the input file. So we are now moving on to the second digit, which is the digit 2 itself, okay? So that means, on line 6, yes, everything is red, and 2 is within the range that we're expecting. So now we can say, yep, CH got the value of 2. Then that means we have to move on to line 8, and we have to do a recursive call again. So R gets f of n times 4 plus ch minus quote 0 quote. I hit the wrong key. I keep hitting the wrong key too. Something is not right. Why is it wrapping around? This is rather mysterious. Did I accidentally turn on auto wrap or something? Yep, I did. Well, that was a quick debug.
How does it know when to auto wrap though?
Sorry?
How does it know when to auto wrap?
I must have hit something that's the key, shortcut key to that.
Okay.
Okay, so what is n? N is 1, right? And then ch is quote to quote. So when I do this calculation, it becomes 4 plus 2, right? 4 plus 2, which is 6. So effectively, I'm trying to figure out what is f of 6. Well, there's only one way to figure out what is f of 6. Ask function f, right? So we have to call f again, this time with the value of 6 in n to start with. Okay. So once again, sorry? Oh, we're not done yet. We have two more instances to go.
Yes.
So on line 6 this time we are reading 3, right?
Yeah.
3 is, we read a character, it is between 0 and 3, we're good, okay? So on line 6, we end up with ch getting the value of the ASCII code of 3. And then on line 8, here we are doing the same big mess again, which is r equals to f of 4 times n plus ch minus the ASCII code of 0. And this time I'm going to do it a little bit quicker. 4 times n is 24 because n is 6. ch is the ASCII code of 3. ASCII code of 3 minus the ASCII code of 0 is 3. So it is 27. So we have to figure out what is f of 27. All right. So we go to line 6 again. Oh, forgot one thing. It's a convention. This one is really hard going forward, but coming backward is easy. Okay, so we are calling f with n getting 27. Okay, beginning with 20. Okay. There we go. Much easier to see this way. So on line 6, this time, what do we read back? We just cleared away 1, 2, 3. What is the fourth character? The carriage return character, which is the \n. So the read is successful. Scanf returns a 1. Is it between the ASCII code of 0 and 3? No. So it is true and, well, it's actually true and false because it's only failing the last one. But it is still false, right? So ch is basically the line feed character, ASCII code. Then where do we go? We go to line 12, r equals n.
How do we know that the line feed character is less, not less than 3?
I don't have that memorized. Does anyone in here besides me?
You don't need to. Okay, tell me, according to what you know about digits, what do you think is between the ASCII code of 0 and the ASCII code of 3?
1 and 2.
Is line feed one of them?
Yeah,
That's it. You just answer your own question.
Well,
that's
no, I mean, this is just the practice stuff. The test is going to be way harder.
it's
I'll give you the full ASCII table.
Thank you.
what kind of stuff.
I don't. I think it's.
Okay, so now we move on to line 12. Line 12 is doing what? Line 12 says r gets n. That's what it says. And r gets n is 27, so r gets the value of 27. After line 12, we go to line 14, which is returning r. Now this is important. Line 14 itself is not important all by itself, but what it does with 27 is important. Okay, so at this point, I'm at the end of a rental contract. I'm ready to return the truck to the guy or the person who rented the truck to me in the first place. So the question is, who needs to use the value of 27 and where? Okay, so we track down who started this invocation. It's this guy here. So it was this expression, which is on line 8, that call this thing here. So that means when we continue execution, which line am I going to? We're going back to line 8 to finish up some unfinished business, right? So we basically say R gets the value of f of 27. But we know what is f of 27 now. It is just 27. Cool. After line 8, where do we go? After line 8, we go to line 14 right away. Okay, so we go to line 14, and what are we returning?
27.
Exactly, we are now returning 27 again. And who cares about this return value? Line 8. This invocation is coming from here, and that is line 8. So now we are back to, guess what? Line 8. And line 8 says R gets 27, because f of 6 in this case is returning a value of 27. Then we move on to line 14, and once again we return 27. And the question is, okay, who asked? Oh, I asked, and I'm also on line 8. See this call that triggered this invocation? That's where we're returning to. So we're going back to line 8 to finish that unfinished business. R gets 27, go to line 14, return 27 as a value. And then we say, okay, who cares about this value? Who calls this? Printf on line 19. So now we return to line 19. So we can say, okay, whatever we're printing is printing 27. And we are printing using a %d as a format, which means we're printing 27 as a base 10 number. So 27 is 27 when you print it out. So 27 is the output of this program, assuming the input is 1, 2, 3, and the enter key. Just like the other program, this one compiles. So I strongly recommend you guys to compile this program and to actually test it out. All right, we are running out of time, so I'm going to end today's lecture. Question 5 and 6 will be covered, 6 and 7. 6 and 7 will be covered in a YouTube that I will publish later today. If I don't, remind me, send me a little email and remind me about questions 6 and 7. And then on Monday, we can talk about any of these topics. If you need clarifications or want me to demonstrate another recursive subroutine, we can do all that on Monday. All right, have a nice weekend getting ready for the exam.